Alright guys, you are welcome again to another tutorial series. Today we shall be looking at a list function called map. There are a lot of things we can discuss on the map function, but basically what we want to discuss today is the data type. We want to see how we can determine the data type of the map function in SML. As we said in our previous lesson, that SML is a simple meta language, it's a functional programming language, and it is strongly typed. Now, so very quickly, this is just a short tutorial for us to see how to determine the data type of the map function. So here is the data type of the map function, but how is this generated from the SML? How can we determine this on our own? So that's the essence of this short tutorial. Now, so as an introduction, let's look at what a map function is. A map function is a list function. That is, it operates on a list. That's why you call it a list function. We all know what a list is. So if I put in something like this, I put in a list like this, I put in this, that is a list of numbers. If I put something like this, 2, 4, 6, so that is a list of even numbers, and so on and so forth. So that is a list. Alright, so let's now see how the map function is defined. How do we create a map function? How do we define a map function? So if you look at this example here, you will see that this is the fun, the fun function, that tells us that we are about to create we are about to define a function, and the very first is a space, and the very first variable that we have here, that is the name of that function that we are defining. So this is the name of the function that we are defining, and we have another space. So that function takes another variable f, and it takes new. This new is a keyword in map. It represents a function with empty element. So new is the same thing as saying a function with empty element. So that is what we mean by new. So as you can see this, so if I clear off all the elements here, if I remove this element one by one and I clear them off, so this becomes an empty element. It's an element, but it does not have any value. So that is what new represents. So let's see how a list map function is defined. So first, if what a map function does is that it, as the name implies, it maps the function. This f represents a function, but it is a variable here. So what it does is that it maps a function to the list. In other words, if I have, for example, a function that if I create a function that squares, let's say I have a function that squares. So a function called square, and what that function does is that function takes say it takes x and the functions multiply the x at least twice. Alright, so I want to be sure we are getting this correctly in SML. Let me just do a quick check of that. I think we're okay. So if we have such a function like that, yeah, I think we're okay. So if we have a function that takes a variable, so this is the name of our function, square, and it takes a variable x, and what it does is that it multiplies there, it squares it. So this is a function. Now this f can be a function like square, like that square, so that you now apply that square to each element of the list. I hope you understand that. So if I apply this function square to this element, so what I'm going to have is, then I'm going to have another set of lists, which is 4, 16, and 36. That is what we're talking about. So if I map this function square to this list, then I will have this. So from this explanation, a map function operates on a list, and it returns a list. Don't forget that a function takes an input, performs some operation on that input, and returns an output. So the input to a map function is a list, and the output is also a list. We need to get that one very clear because we are coming to the data type. So, and what the map function does is that whatever functionality that we declare for the function, it maps it operates on each element of the list, like we explained. So this is a function. This represents a function which can be anything. It can be square, it can be cube root, it can be add plus 1, it can be subtract, it can be whatever. So this is how the map function is defined. It takes f, a function, and it also takes a list. This representation is referred to as query. This is referred to as query in one of our tutorials. Hopefully we'll be able to talk about query. Query is a principle just to let you know that the function can take intermediate give intermediate results. So but just know that this notation is referred to as query. This is a query notation because this list, this map function, the list map, is taking function f, and it's taking a list, but it's taking them one at a time. So let's go back to how the list function, the map function, is defined. If this list is a new, then the result will be new. Don't forget we said that our map function must also give us, it takes a list and it must return a list. So if the list is empty, then definitely the result will also be empty. So we need to define this. This helps our iteration, our recursive function. This is recursive programming to terminate. All right. So if we apply a function to this new, then we also get new. That is clear. Now if the list is not new, then this is how we represent a full-fledged list in SML. So this is the pattern, and what this pattern is just saying is this: n is the head of that list, while ns is the rest of the list, like the body of the list. So from data structure, we understand that a list has a head, and we have the body of that list. So for example, this is a list 1 2 3. All right, the head of this list is 1, okay, while the body of this list is 2 3. So the body of a list is also a list, but the head of a list is just an entity. It's not a list, just an entity. So we should get that very clear. It's very important for us to understand that. So if we have a representation of the list as it is here, and you can use any representation that you like, any characters. You can decide to use ls to represent a list, L, and you have double column ls is the same thing, or you can use k or ks, it doesn't matter. So all you need is for you to know that this must be there. This shows the joining the head to the body of the list. So it's a pattern matching in SML. So you need to understand that clearly. So what do? We now define that if you encounter a full-fledged list, break it down into two parts. That's the definition of this. It breaks it down into two parts. It breaks it into n and ns. Apply the function f to n and join it to the head. This is joining. Okay, so this is the head. Join it to, then recursively apply the same function, list map, the same map function on using f and the body of the list. It's a bit tricky there, but it's not that difficult. You just need to give it time, you will understand it. You see, let me say that again. This is a full-fledged list. It has a head and it has a body. To define what the map function does, you apply the function to the head of that list, then you join it. That is, you are still maintaining a list. This is still a list, and this is the head and this is the body. So you have performed an operation on the first element, which is the head of that list. Then recursively you are performing the same operation, this same thing. You are performing the same operation again using F, but instead of the whole thing, you are now performing on the rest of the list, which is ns. I hope that is clear. You can look at it here. That's the same way it works here, like I explained earlier. So this is a list 2 4 6. So if I apply this function square to this list, so what it will do is that it will start from here and look at the function and look at it. That is the list new? No, the list is not new, so it does not match this. It won't give us new, but it comes to this and say that okay, it's a full-fledged list. So what does it do? It then pick the head of that list what is the head of that list here? That is 2. And apply the function f to that head. What is the function f? In our own case is square. So the function is square, and this variable x will now become 2. Then it performs this operation on that, then it becomes 2 times 2, which is 4. Then it writes 4 down as a head, waiting for the remaining operation. So it's forming a list. So recursively again, it goes back and picks the body of the list. So what do we have in the body of the list? This is 4, 6. So it applies again the function to the list 4, 6, which matches this. Then recursively it picks the head of that body, the rest of the body, which is the head of the rest of the body is now 4. It applies the function again recursively on that 4, then it becomes 16. Then it puts 16 here. Then it comes back again and look at what is the rest of the body of that list. So we now have what? We have 6. So that is the only thing left. That is 6 as a list, not as an entity. So it comes here again, alright? Recursively apply the function on the head of that list. So what is the head of the list? 6 is 6. Okay? And what will be the what? The rest of the body? It will be empty, because by the time you pop out 6, the rest of the body will be empty. And it applies the function on 6 and multiplies 6 by 6, it becomes 36. Alright? Then it comes again, recursively apply the function on the rest of the list, which is what? Empty. So by the time it comes again, the operation always starts from top. You see that it now matches this nil. So it matches this nil, and so what it will now then do is that it will now match 4 to 16 to 36 to nil, which gives us a list. I hope you understand that. It's very tricky, but by the time you give it more time. So what we have in that operation will be this. You first of all have 4, you have 16, you have 36, then you have join it with what? A list. So this is the same thing as this. Okay, so this is the same thing as this. That is what we have here. Okay, so because what you have in this, you join to this to this, and this to this. That's why we have that. But that's not where we're going. We need to understand that for us to be able to now understand the data type. Now let's now look at the data type. In defining the data type, it's a bit trickish, but we carefully look at it so that we can understand it. Data types means that we want to know the type of the element involved. It can be an integer, it can be a real, it can be an integer, it can be a real, it can be a char, it can be a string, whatever. So we want to know what is the data type of the elements that are involved by generalizing, because here we are not using any specific values, we are not using numbers, so we want to use what we call we want to use generalized data type, not specific data type. We want to use what we call a polymorphic data type, that serves as for any kind of data type. So we want something generalized. We don't just want to use int or real or char, those are specific. We want to use a polymorphic data type. which can be A, B, C, or whatever. So how do we write that? Now you will see here that to write the data type for the function list map, first you write fn as you have there. Then you see that there are, how many variables do you have here? Here we have the function is list map, so the name of the function is list map. It is taking two items, which is f and nil, and it is returning just one item, which is nil. Okay, so it's taking one item, which is f, and the one item that it is taking is also a function. How you will know that that is a function is from this operation here. You will see that in this operation we are applying that f to an entity. Alright, so generally we just say, okay, this is a prime, picking the first letter of the alphabet. So the function is taking an entity. The data type, we don't know what kind of data type it is, so it's arbitrary. And every function we always return an output, and it's returning another kind of data type. We don't know, we can just generalize that. Alright, so after that, the list map that we are writing the data type is also taking another variable here, which is new, and we know that is a list. But the type of that list we don't know. It can be an int list, it can be a string list, it can be a real list, it can be a boolean list, we don't know. So we just say a C prime, that is another one. Just use another arbitrary data type and say C prime, but we know that it is a list. Then finally we have an output. So it gives us an output, an arrow. We know that this is also a list. This is a form of list, but we don't know the type of list that it is. We can say it is D prime. Alright, so here we have used polymorphic data type to represent polymorphic variables to represent our list map function. Now we will now try to examine critically the definition of our list map, our function, and to see some of the data types where there are repetitions, where the same data types are involved. Sometimes when you are writing data type for functions, each of them might be unique like this, and it will be A, B, C, D like this. But before you conclude that, you need to look critically and examine the way the function is defined, whether there are duplication of data type. Now, so let's look at that. If you examine this place, we cannot see much here. You just know that this is a function, this is a list, and this is a list. Alright, when you come here too, we see, okay, this is a function, this is a list, equals to, alright. Then here we see something here. We see that this function is operating on the head of this list, and we know that a list we always have the same data type. That is very important for us to know. A list we always have the same data type. So if this function is operating on the head of this list, because this is n, this is n, it means that this function is taking a type of this list. I hope that is clear. It means that this function f is taking a type of this list. So here we are said that this function is taking A, okay, and here we have said that this list is what? Is C. So it means that if this function is taking A, then this list must also be A. So we change this one to data type A. I hope we're getting it. So starting from here, we can change this to C and this one C, but we normally preserve the first occurrence and change the succeeding occurrence, okay, the subsequent occurrence. So I hope that is clear. Since this function is taking a type of this list, is taking n, and n is the head of this list, then it tells us that this list and the input to our function must be of the same data type. That's one thing we can see there. Another thing we can also look very well here is that you will see that the results of this function, because when this function is applied to n, the result is the whole of this. The result of this function is the head of the output. The result of this function, because when this function is processed, it gives us a result, and that result becomes the head, because this is showing us that this is the head and this is the tail. So the result of applying function f to n, which will result in an output here, will be the head of this of this, which means the whole of these results must be of the same type with the output of the function. So with that understanding, when we come back to our definition here, we have said that function f is take data type A and returns B. Then it means that the type of this list must be the type of the output of B. So we change this to B. Very, very important. I hope we understand that. I hope we get that. It's very trickish, but it's something that we can understand. Since the function gives a result of a data type B, and the result is the head of this list, which means the head must be the same data type as the whole list. So if this data type is B, invariably this data type must also be B. So we keep examining. Is there any other thing that we can see from here? There's no other thing we can verify anymore. There's no other thing we can verify, and that is how we arrive at this. I want you to take a look at it critically. Is very important in programming language, to be able, especially in SML, to understand how data types are generated. Thank you very much for listening. Please do give us a like if you benefit from this tutorial, and if you don't like the tutorial, please give us a dislike, and you can make comment. All this will help us to improve on subsequent tutorials. Thank you very much, and see you in the next tutorial.